Welcome to Limiting Reactants Part 2. Now before you start this video, I would highly recommend that you revise your reacting masses and also watch Limiting Reactants Part 1. If you've done that, then let's begin. So in this question, we want to know what mass of aluminium chloride, the product we get, if we have 13.5 grams of aluminium and 42.6 grams of chlorine. Now it's not as easy as just adding them together. We have to work out which of these is our limiting reactant. So first of all, we're going to identify our reactants, so aluminium and chlorine. Next, we're going to make a table like this. So mass, moles, and 1:1. I'll show you how this works. So we're going to write down the reactants on the left, and the squiggly line is just there to show the difference between reactants and product. Now we're going to write down the mass of the reactants. So we know aluminium is 13.5 grams, chlorine is 42.6 grams. Then we're going to convert these mass into moles. So divide by relative atomic mass for aluminium. So on the periodic table, we can see that the mass number for aluminium is 27. Since we have one aluminium, it's just going to be 27. So divide by 27 and that gives you 0.5 moles. As for chlorine, we're going to divide it by the relative molecular mass. And chlorine is 35.5, but we have 2 chlorines in our formula. So that means it's going to be 71, and that gives you 0.6. Okay, once we have the moles, we want to work out which one was the limiting reactant. So we have to compare them as if they were 1:1. Meaning that for aluminium, since there's a 2 in front of it, I'm going to divide it by 2. And for chlorine, there's a 3 in front of it, so I'm going to divide it by 3. And that gives me 0.25 for aluminium and 0.2 for chlorine. We can see that chlorine is the limiting reactant. Okay, so we're going to use this to work out the moles of the product. Now, the product aluminium chloride has a 2 in front of it. That means we're going to times the moles by 2, giving us 0.4 moles. Then we're going to times it by the relative formula mass to work out the mass. Again, we have one aluminium, so that's 27. We have 3 chlorines, which is 35.5 times 3, giving us a total of 133.5. So we're going to do 0.4 times by that number, 133.5, and that gives us 53.4 grams. So we can see that it's not actually adding them together. If you added 13.5 with 42.6, you would have got the wrong number. Okay. Let's try another question. What mass of iron is formed when 8 grams of iron oxide reacts with 2.16 grams of aluminium? Okay, so just like before, we're going to first identify our main reactants, which is iron oxide and aluminium. Then we're going to make the table, put the reactants on the left. Now from the products, we have 2 products, iron and aluminium oxide. Which one do we want to know about? The question says iron, so iron goes on the table. Okay, next, let's fill out the table starting with the reactants. We know the mass of iron oxide is 8 grams, and the mass of aluminium is 2.16 grams. So we're going to divide by the relative formula mass to turn mass into moles. Now we have 2 ions, so that's going to be 56 times 2, and we have 3 oxygens, which will be 16 times 3. Giving us a total value of 160. So 8 divided by 160 gives us 0.05 moles. We're going to do the same thing for aluminium. So aluminium is 27. We have 1 aluminium, so that's going to be 2.16 divided by 27. 0.08 moles. Okay, next, can we see, are they 1:1? Well, in front of iron oxide, there's nothing, which means there's a 1 there. So that will be the same. 0.05 moles. But in front of aluminium, there's a 2, so we have to divide the moles by 2, giving us 0.04 moles. Okay, so now again, the limiting reactant is going to be this one. We're going to use this to work out the moles of the product. So the product iron has a 2 in front of it, times it by 2. That gives us 0.08 moles. And then finally, we're going to times it by the relative atomic mass. Iron, there's just one of them, so it's going to be 56. So times it by 56, and that gives you 4.48 grams. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.